Okay, so here's another question where we've got two containers of gas. In the previous one, we were taking one container and squashing all of that gas into the other container. This one's slightly different. We've got two containers and we're going to open the valve between them so that they can mix. So it's a little bit different, but we go about it pretty much the same way. Okay, so first of all, we need to calculate the pressure in the tank. So that's this one here. And we've been given a volume. Remember, use the units to help you, meters cubed, so that's a volume, and a number of moles, so remember that's little n, and then we've got a temperature, we've got to convert that to Kelvin, so that's what we've got, and we're being asked for the pressure. Now we can see that that one is the PV equals nRT version, and we've got everything we need, so it's just going to be a matter of working out what the pressure is. And so that comes out as 9.1 times 10 to the 6 pascals. Okay, so now on to the interesting bit. Here we've got our tank that we've just looked at. So we now know everything about that tank there. And now we've got this little helium cylinder. So what we know about that is cylinder of, there we go, there's the volume, and there's the pressure, and there's temperature. Don't forget to convert to Kelvin again. But what we don't know this time is the number of moles. So that's going to have to be the first thing that we work out. And that's going to give 41 moles of helium. Okay, so now we're told that the valve is opened and the gases are able to mix. And so what is the final pressure? Well, now it's just like we've got one big container. So if we think about that one big container, what do we know about it? Well, we know that its volume is just the volume of this one plus the volume of that one. So if I add those two together, I just get, oops, nearly messed up there because that one's 10 to the minus 2 and that one's 10 to the minus 3. So very careful with that. So we've got our total volume. We know that the temperature is staying the same. We know the total number of moles that we've got because again we've got 45 moles here, 41 moles there. So that means we've got altogether 86 moles. And we know what the gas constant is. So the last thing we're working out is what we're after, the pressure. So putting all of these numbers in. We get, for not a bad 3 marks there, I would say. .5 times 10 to the minus 7, 10 to the 7 pascals. Okay, so that's how you do one of those questions. What's the total number of moles? What's the total volume? And then proceed as normal.